I request Dr. Vidyuta, Assistant Professor at the Kupsam Shastri Research Institute, to introduce our resource person.
Now I am going to introduce the next speaker. Rajarajeshwari is a Max graduate who has done her MA in Sanskrit. She has done her MPhil at the University of Madras in Indian Mathematics and has submitted her thesis in Indian Astronomy at the same university under the guidance of Professor M.S. Sriram, and is awaiting her Viva examination shortly. She has conducted a couple of workshops on basics of Indian astronomy. She is currently with the CIKS IIT Madras as project staff working on a commentary of Brahmasputa Siddhanta. I now call her to give her talk on introduction to astronomy.
Shri Gurubhyo Namaha, Namasabai. I'm Rajarajeshwari. I'm with you to share a glimpse of basics of Indian astronomy. Let us start this talk by invocating Lord Ganesha. Pritim bhakta janasya yo jhanayate vignam vinignan smritaha tam vrindaraka vrindita padam natva matangananam patim sadghanitasya vachmi chatura priti pradam prasfutam samkshiptakshara komalamala pade lalitya leelavatim. This is the first verse in Leelavati. Just when I come to this is what we can expect in the next 40 to 50 minutes. I'll start with the introduction. Much of the introduction has been given here by all the professors here. Let me start with the tracing back of the science called astronomy. Whatever science we need to trace back in the Indian tradition, it traces back to Vedas. The traces of in astronomy we can find in Samhitas and Brahmanas. Generally they are dated beyond 2000 BC. Astronomy, it is translated as Jyotisha in Sanskrit. Jyotisha, whenever we hear now, the present kids, they know it as astrology. But then it was not like that. Jyotisha comprised of 3 branches of science: mathematics, astronomy and astrology. Jyotisham, I'll call it as Jyotisham, I won't use astronomy. Jyotisham is one of the Shad Vedangas. Yes sir, I'll just go. Shad Vedangas, and as sir said, Jyotisham was considered as the eye of Vedas. This sentence, it is there in Siddhanta Shiromani, says Veda Chakshuk Kiledam Smritam Jyotisham. Jyotisham is considered as the eyes of Vedas. When we trace back Indian astronomy, right, after Vedas, if we need a text, a solid text to start with, to begin the study of astronomy or Jyotisham, what we have is Vedanga Jyotisha. The text Vedanga Jyotisha is attributed to Lagada. The text Vedanga Jyotisha gives mathematical algorithms for all our calculations. There are passages that describe sky, sun, moon, seasons, months. This verse, whatever I have taken here, it gives the number of days, the ritus, there are 6 seasons. It says Shat Ritavaha, means there are 6 seasons. Masa, Dwadasha, Saura. Saura Masas are 12 in number. I am not going into detail. This This is just a sample, one verse from the text Vedanga Jyotisha. After Vedanga Jyotisha, if you want to take a text to read, what we get or what is available is Aryabhatiya. The Aryabhatiya is a Siddhanta text. Generally, the astronomical texts are broadly classified as Siddhanta text and Karana text. The Siddhanta text, they deal with the astronomical literature, whereas the Karana text gives us the algorithms and the formulas. We are now restricting ourselves to the Siddhanta text. So, Siddhanta text, they deal with the astronomical literature. There were 18 Siddhantas. It was recorded that there were 18 Siddhantas. What is available to us is the 5 Siddhantas, so Surya, Paulisha, Romaka, Vashishta and Paitamaha. That too we get from the Pancha Siddhantika of Varaha Mihira. Among these, Surya Siddhanta, the name I think we should be familiar with. The well-known Surya Siddhanta is the earliest of the Siddhanta text. These Siddhanta texts, they deal with concept of time, spheres, planets, their motion, their position, eclipses, rising and setting times, cosmography and instruments. There are separate chapters dedicated to each of the concepts. In most of the Siddhanta text, the chapter order will be like this. The first chapter will be Madhyamadhikara. Madhyama means mean. The chapter deals with the mean longitude of the celestial bodies. This chapter gives us the procedure to find the Ahargana. Ahargana means the number of days elapsed since an epoch, given an epoch. Since we may take the starting of Kali as an epoch. There is another system of finding the Ahargana using Shaka year. So different authors use different epoch in our Indian astronomical text. The chapter also gives the revolution of the planets, and it also gives the how to find the Madhyama Graha. We'll come to this term later. The second chapter usually will be Spashtadikara. Spashta means true. This chapter gives us a clear idea of finding the true longitudes of the celestial bodies. True longitudes, and while finding the true longitudes, they also deal with two corrections, namely Manda Samskara and Shigra Samskara. We'll be dealing in brief about these terms later. The third chapter is Triprashnadikara, which is considered as the most largest and the most important chapter in every Indian astronomical text. Tri means three, Prashna means question. Prashna means the chapter that deals with the three problems. What are the three problems? Dik, Desha and Kala. If we want to find the position of anything, say anything, I want to find the position of myself. Now, I need the direction where I am, the place where I am, and the time when I am standing here. So, Dik, Desha and Kala. To find the position of any celestial body, we need to solve all the problems related to these three things, and it is extensively dealt in the Triprashnadikara chapter. And the last two chapters are Chandra Grahanadikara and Surya Grahanadikara. As the name suggests, Chandra Grahanadikara deals with the eclipses of moon, and Surya Grahanadikara deals with the eclipses of sun. And also there will be a chapter or section in most of the Siddhantic texts that deals with the instruments that are used for observational purposes. It is called Yantradhikara. And another biggest section will be Goladhyaya. This is one important section that deals with the spherics. As the name suggests, sphere or spherics, the calculations, whatever we do, it will be mostly application of spherical trigonometry. I guess many maths teachers are here. Whenever we teach trigonometry, the questions usually the kids ask is, why do I need to learn trigonometry? What is the purpose, man? Sin theta, cos theta, why should I remember the tables? So this is one good application we can let them know to know they are interested in space, they are interested in aviation. We can just let them know there is a path to follow when you are excellent in trigonometry. easy for us. Okay. When we started with the Siddhanta text, we told it deals with the astronomical literature. That doesn't mean that there will be paragraphs and essays in the book. Our Indian text always, it is in algorithmic nature. The verses will be very short, very clear, and that is the speciality of our text, Indian astronomical text. For example, we are just going to discuss about Aryabhatiya. This is the first Siddhanta text available to us. The nature of the text is very cryptic. There are just 121 stanzas in the entire text. The entire text can be divided into 4 sections: Geetika Pada, Ganita Pada, Kalakriya Pada and Gola Pada. The Geetika Pada, it is similar to the Madhyamadikara. It gives the notation of numbers, it gives the revolution of the planets and the associated parameters. Ganita Pada, it includes all the mathematical algorithms along with trigonometry. Kala Kriya Pada, Kala means time. So all the calendrical concepts, planetary models, the procedures to find the planetary positions that are given in the 3rd section. Gola Pada, as the name suggests, it includes the spherical astronomy and the problems which are related to the diurnal circle. The diurnal problems are dealt there. One thing which is very famous is Aryabhatiya text is it gives all the modern values, it gives all the modern sign values. It's very famous among us. So I'm just going to touch that topic, how Indian astronomers calculated the sign values. I'll touch the topic a bit. Before getting into that, why do you need sign values? Why do you need, what are the revolutions given? What are the big numbers that are used in our text, given in our text using the short algorithms? This slide is just an example. I'm not going to elaborate this slide. This is just an example of the numbers given in that text in a form of a short verse. They have, Aryabhatiya has used the Aryabhatian numeral system to denote these numbers in the form of verses all throughout his text. I'm going to literally skip this slide because we have seen this slide many times. Ma'am has told, sir has told. So I have just listed out the astronomers and their important astronomical and mathematical works in this slide. When we talk of astronomers, Indian astronomers, we have to give a special mention about Kerala School of Astronomy. See, after Bhaskaracharya's time, there was a huge gap. We didn't find any books related to Indian astronomy. At that time, until nearly 19th century, the Kerala School of Astronomy, the astronomers have contributed a lot to the field of Indian astronomy and mathematics. Okay, let's come to the topic. So, sign, this picture, the picture here in the down is how we denote sign in our general way, right? But Indian astronomers have taken, I think ma'am have already explained it, still Indian astronomers, we take only the half chord, we don't take the full chord, we take the half chord which is marked as theta as our sign. So these computations, it is first found in Aryabhatiya, Ganita Pada. He has given how to compute the sign values geometrically and how to construct the sign table. He has considered a circle and or an unit circle, and generally the radius will be denoted by R, and the value which we take general value for R is 3438 in any or in most of the astronomical text. So considering this, how did he find the values? This is the algorithm given by Aryabhatiya. So Aryabhata means Aryabhatiya. So take the circle, consider one quadrant, so which will be 90 degrees. Divide each quadrant into 24 arcs. So it is there. That is what the formula will be given by the verse. We'll go to that. And then drop a perpendicular from each line. So using using the verse, whatever he has given, I'm not elaborating the method. Okay, that geometrical picture was given in Aryabhatiya, and the formula was given with the before verse, whichever we saw. The formula says, yes, please. Can you move? Okay. So the formula says Pratama Chapa Jardat Yai Runam Khanditam Dvitiyardam. So Pratama Jardat from the first sign, Dvitiya is second sign. I'll explain the next. Tat Pratama Jardamshaihi Tai Runani Sheshani. So he says, divide the first sign by itself and unani subtracted from the result subtracted from itself, it gives the difference between the first sign and the second sign. This is the algorithm given by Aryabhatiya. On generalizing, we get this relation, exact relation given in Aryabhatiya. We derive it. I'm not going to the derivation. So the formula is, the algorithm is this, and we derive this formula, and the value taken by Aryabhata is 1 by r sin alpha, which will be 1 by 225, 1 by 225, which will come around 0.0444, but more approximate, they didn't stop with this. Not everybody agreed with Aryabhata. Okay, this is the value they take. This is the value for verse sign and all. They kept improvising the result, and around 15th century, Nilakanta in his Tantra Sangraha has revised the value, and he has taken better approximation for r sin alpha as 1 by 233.5. So this is one example on how our Indian astronomers has dealt with the basic trigonometry function, which is sin theta. So as I said, far more accurate values are there in Ganita Yukti Bhasha. Why we celebrate Kerala astronomers is one reason is this. Madhava, a Kerala astronomer, has given formulas or derivations for infinite series and the relations. This is one of his relation, which is for r sin theta. From this formula we can obtain, or we obtained the r sin values of 24 r sines starting with 225. So this is a tabular column which shows the values taken or given by Aryabhatta, Bhaskara, Govinda Swami and Madhava. Madhava's values are more or less same as the modern values. Okay. Before going into the other section, I just want to give you a glimpse of the basics things we need to know in Indian astronomy. The first thing is the celestial sphere. This word we generally hear. I think sir also showed similar diagram. So what is the celestial sphere? Celestial sphere is nothing but the starry sphere, hemisphere. When you look up, the hemisphere, whatever you see, that is the astral sphere. So technically, if you are here, this will be your celestial sphere. And then equator and poles. See, we all know the definition of equator. That is different. Just giving. So the Earth revolves, rotates, right? Rotates along an axis. And the plane which is perpendicular to the axis, the great circle which lies in the plane which is perpendicular to the axis is called the equator. That when expanded, it is known as the celestial equator. And from the earth, when we see the movement of sun, it seems to trace a big circle in the background of the stars, that we name it as ecliptic. As sir said, the ecliptic and the equator, there is an obliquity of 23.5 degrees, and the point where the ecliptic and the equator they meet or they intersect, that is called equinox. We know vernal equinox and autumnal equinox. The point where the equator and the ecliptic meets and where the sun starts its northward motion. It is called vernal equinox, or we call it as Meshadi. And the point where the sun starts its southward motion, it is called autumnal equinox. Okay, when we speak of equinox or ayana is movement of sun, so this shows how we measure the declination. This is the path of the sun, and this picture is just to show how we observe the motion of the sun around Earth. And this is the whatever we see in the sky, like starry background. We have acknowledged 27 nakshatras. In Vedic times they have acknowledged 28. They have even acknowledged Abhijit. And interesting thing is, in Vedic time they didn't have the divisions of Rashis. Vedanga Jyotisha, we could see the division of Rashi mentions in the textbook. And this is how we visualize, right? So Makara, Kumbha, these are the constellations, and we could see a circle-like thing, right? This circle-like thing is technically a belt. It is called zodiac belt. The zodiac belt will be parallel to the ecliptic. The two, imagine ecliptic and two parallel circles in 8-degree difference in both the sides of the ecliptic. That is called the zodiac belt, and with reference to that belt only we are doing our calculations astronomically and astrologically. So this is just a picture to depict all the circles whatever we have seen now. So imagine this is us, the observer. You are standing in a place, and this is your horizon and your equator. See, whatever we are seeing now, it is not just the equator, ecliptic, just have a bigger picture. It's celestial equator, and this is the path of the sun along with the stars and constellations. So this is the celestial north pole and south pole. So with this we proceed. This is another pictorial representation. Okay, so when we have all these things, we are supposed or forced to talk about coordinate system. We know the coordinate system, we use latitude and longitude system, like equatorial system. So in Indian astronomy, the ancient Indian astronomers, they have used ecliptic coordinates to measure the latitude and longitude. That is, with reference to ecliptic, they measure the longitude and the latitude. This is the vernal equinox we were talking of. So in Indian system, this vernal equinox, it does move. It does move with respect to the axis of the earth. Due to the motion of the axis of the earth, this moves to and fro. That's why we see the rising of the sun towards north and towards south. We call it as Uttarayana and Dakshinayana. When we every day try to record the rising of the sun, we could easily see through our eyes also. So this is, movement of the ecliptic is the reason for that, and the change. This is the reason for changing of seasons also. So when we take, during our calculations, if we take this moving vernal equinox, then we call it as Sayana. When we take this vernal equinox is fixed, the first point of Aries is our reference point, then it is called Narayana. These two this is the major difference between the Indian astronomy and Western astronomy. Western astronomy takes the first point of Aries as constant. We don't take it. We take it along with the corrections, always. And with reference to horizon, we calculate the azimuth and altitude. With respect to equator, we calculate the right ascension and the declination. These terms were explained yesterday, so I am not going in deep. Why did we saw all these terms? Because I just want to discuss one important contribution of Indian astronomers, which is the planetary model. Sorry, what? Correct? So, one important contribution of Indian astronomers is the revision of planetary models. So, we are just going to see how it was considered, the planetary model system, who revised it, and what was the revision, and what is the significance. So, okay. The present or the modern astronomy, the planetary model system, it is based on Kepler's law. We all know that. The Kepler's law has the influence from, actually it is based on Newton's law of gravitation. And the results we arrive from Newton's law of gravitation, it is nothing but the Kepler's law, which is totally kinematical. And the similarity between Kepler's model and our revised planetary model is just what the main point of this session. So Kepler's model, again, laws are kinematical, and the revised planetary model, which was proposed by Nilakanta in 1530 around, they draw many similarities and are almost same. Okay, so what are we supposed to do? We need to find the position of a planet. As Sir said, we want to do the astrological predictions. We need to know where Sun is. We need to know where Saturn is. So where do you observe from? We observe from the Earth. So we need geocentric longitudes. But do the planets revolve or rotate around the Earth? No, right? It revolves around the Sun. So whatever calculation we do, it is heliocentric. So the observations can be heliocentric, and it should be made into geocentric, and then we have to calculate the effects of those planets, the horoscope, everything. So for these, we need to know the relationship between the planets and the Sun and the Earth. With respect to Earth, Mercury and Venus are considered as interior planets. With respect to Earth, Mars, Jupiter, Saturn are considered as exterior planets. There is no mention of Rahu, Ketu and all. There is no mention. As it is mentioned as nodes. That's it. We don't consider the Baki to Neptune and Pluto and all. There is no mention in ancient text at least. So I'm starting with the ancient Indian model of the planetary system, which is called, we name it as conventional model. So what did they do? How did they consider? See, first they calculated the mean position of the planets. That's what we do, mean position of the planets, and they multiplied it with the revolutions made by them. They took it and they called it as Madhyama Graha. They call it as Madhyama Graha. And then they made two corrections. These two terms we came across, which are Manda Samskara and Shigra Samskara. The Manda Samskara is nothing but the correction due to the eccentricity of the orbits of the planets. We all know the planets revolve around the Sun in their own eccentric orbits, and the aerial velocity traced by them are equal is a constant in their own orbits. Correct. So having this in mind, they did the Manda Samskara. Manda Samskara is applying the correction which gave us mean heliocentric longitudes. And then we have true heliocentric longitudes. And then we need to convert it into geocentric longitudes. We need another correction which is called Shigra Samskara. Okay, fine. So what is the problem here? Ancient astronomers, at least from Aryabhatta, those periods, they considered the interior planets when they calculate the longitudes and multiplied with the mean motion. They consider the mean Sun itself as the heliocentric longitude only for the interior planets. But for the exterior planets, whatever they obtained, they considered as heliocentric longitude and then they converted to geocentric longitude. This was a problem. This was a problem not only for us, even in Ptolemy's model there was an issue. He considered only Mercury as interior planet. He didn't even consider Venus. And Copernicus, who even revised Ptolemy's model, he didn't do the necessary correction in the heliocentric model proposed by Ptolemy. The correct thing was proposed or acknowledged, let us say. It was acknowledged only when the theory was proposed by Kepler in European. Okay. So now, see, we all know the non-uniformity of the motion of the planets is due to the eccentricity, and here, let's see, this is the mean planet, okay, this is the mean planet, and this is the Mandocha. This is the center, okay, we observe from here, and this is the mean planet. We need this correction. We need this correction, this XOP, this correction we need. All the observation, what did we say? All the observation we will do only with respect to vernal equinox or the Meshadi. So this is the reference line. This is the reference line with the center O, and this is the mean planet. It revolves around the earth in the circle. And P is the Mandasphuta, and the circle in which it revolves, we name it as Pratima Mandala. And in which P naught revolves, we name it as Kakshavrita. So now our work is to find, how to go back? I need to go back. So our purpose is to find the difference between the longitude of the mean planet and the longitude of the Mandasphuta or P. So the formula will be like lambda O P naught minus lambda O P. This is what we need. For this, we calculated from the difference of the mean planet and this delta theta A is nothing but the angle longitude of the Mandocha. Difference between the mean planet and the longitude of the Mandocha, which is called Manda Kendra. We derive the Manda Samskara from the Manda Kendra along by taking into account a ratio R by K. K is nothing but the Karna Vrita. Karna is hypotenuse. We take the radius of the circle. See, OP is K. OP is the Karna Vrita. Okay. So this ratio R by K plays a vital role while we want to know what correction to be applied to the exterior and interior planets and what is R and what is K. Before going into it, we will just compare the result, the formula what we got for Manda Samskara according to our traditional way and the formula proposed by Kepler. This is the model proposed by Kepler to find the correction due to eccentricity, and here we could see this theta h is nothing but the longitude of the Mandasphuta and the ratio R by R is nothing but the constant minus 2e. Same way, when we want to find to convert the heliocentric longitude to the geocentric longitude, this is the theory proposed by our astronomers for exterior planets. And this relation, again, it goes hand in hand with the Kepler's model and the relation proposed or given by Kepler. So again, So we saw it depends upon a ratio, R by R, right? What is R? R is the distance between the Earth and Sun, and capital R is nothing but the distance between the planet and Sun when it comes to exterior planets. When it comes to interior planets, sorry, there is a typo, capital small r is nothing but the distance between planet and Sun, and capital R is the distance between Earth and Sun, and the values given, the ratio, the values of that ratio given by Aryabhatta matches more fairly with the modern values which we consider as minus 2e even after Kepler's thing. And this is our main problem, right? Interior planets. So who revised it and what was the result? So for interior planets, when we find the Madhyama Graha, so-called Madhyama Graha, that is you find the mean longitude and then you multiply with the mean motion of the planet, you get Madhyama Graha, but mistakenly or for their convenience, they took it as the mean Sun and they applied one more correction, not Shigra alone, they applied one more correction to convert that mean Sun to the current planet so that it will be the mean longitude, and then they converted the heliocentric longitude into geocentric longitude, which was like a lengthy process and which was not necessary, and this correction was made by Nilakanta. Nilakanta, again a Kerala astronomer, he belongs to 16th century AD. He wrote a book, Tantra Sangraha. One of his work is Tantra Sangraha. He revised the models. He gave geometrical explanations in his works, Golasara also. He implied that, he said that, so it is not, it is not the mean Sun to be taken. It is the planet itself, the longitude of the planet itself to be taken and the correction to be applied there. He emphasized whatever you find as Mandocha and you find the true planet, this is the model proposed by Nilakanta for interior planets. So whatever you find, it is not the mean Sun, but it is the planet itself. So you need not apply the Shigroja correction. You can proceed as you proceed with the exterior planets. This is the geometrical picture Nilakanta has given in 4 or 5 verses in his work. We have just tried to give it in a pictorial way. It includes both the interior and the exterior models. We call it as unified model for all the 5 planets. In all the text, we will see only 5 planets, Panchadinam, we will see the way. So it is 2 interior and 3 exterior planets. So to conclude, see all the planets, whatever we consider interior or exterior, they move around the mean Sun in the eccentric orbits, and in turn we see it appears that they are orbiting around the Earth. The model, we cannot call it as geocentric, we call it as quasi-heliocentric. And as we discussed, in Ptolemy's model there were errors and the interior planets were not treated properly, which was corrected by Copernicus, and even Europeans, they didn't accept it till the theory was proposed by Kepler. And with that I conclude, and I thank KSRI for giving me the opportunity, and here I take a chance to thank my professor M.S. Sriram for guiding me all these years. Thank you.
Can you explain us the two curves, number one? Because almost all the horoscopes people are very about the retrograde. Vakragati is there. So if I explain you, it's better if you explain. So that how far is Vakragati is due to astronomical, whether it is in a sign or a because people are very tough seeing, study Vakrama Poitara and Kena and Mokriyanga. So you explain it convenient for them to understand.
So Vakragati is nothing but it doesn't mean the planet is going in the reverse way. there will be a point, the planets will be going together, and there will be a point, one planet turns in the opposite, overtaking. Yeah, exactly. It overtakes the other planet. It seems that the other planet is going in the reverse way, which we, for our convenience, we call it as Vakragati. It is not the planet going behind. And mentions are very less. We are researching in Brahmasputa Siddhantam, sir. Mention is very less due to about Vakragati.
Nilakanta has mentioned about something.
Seems Nilakanta has mentioned earlier works. There was no mention about, at least as far as we have read, there was less mention about Vakragatis. Thank you, sir.
For 5 minutes you can invite some questions.
If you have any questions, you may ask. Ma'am. Jia. I didn't say. I'm sorry. Theta and theta and those variables we mentioned as Yava, variables as Yava Tavat they will use. Angle they just give the number, ma'am, they didn't.
My question is, how do you differentiate dia from chord and sine and sine?
No. Our sign is what we consider. The line is what we consider. The chord is half the chord is what we consider, not the arc.
Not the full chord.
Full, not the full chord. It's the half chord. Where they use? I don't think I have a text.
Do you have?
I'll check.
Please come. Chord is called dia.
அது சொல்லிட்டேன் but no.
Ma'am, the question is, how do we differentiate chord?
They don't use the word for that. He has used as a Maki Baki verse. In Buddha Sankhya it is there. Aryabhatyam he gives an Aryabhata system. We have to convert it. We have to decode it using the number systems. Jya is given. Jya, Kotijya, Dorjya and all they are given. The numbers they have given in verse, we have to decode it. Either in Buddha Sankhya or Kadapayati. Thank you.
Thank you very much.